This is not TPU. It's, as you probably gathered, PEBA. And this is PEBA Air. And this is not. And this is not. Or are they? Let's go. This video is sponsored by PCB Way. Siraya Tech have sent over these reels. There's a few here. TPU, TPU Air, PEBA, PEBA Air. We're going to be looking at the last two today. If you've been subscribed for a while, you might remember me looking at the VarioSure TPU by ColorFab. This is essentially the same thing as TPU Air here. It's great stuff, but it's also the same mechanism that we're going to be looking at with the PEBA Air in this episode, so we'll not go into the TPU aspect at all. So this is, I suppose, a TPU video without any TPU in it. Almost. So what is PEBA? It's a TPE. This is a broad category that encompasses all, or at least nearly all, the flexible FDM materials. The name PEBA means polyether block amide, and mostly we aren't going to get into the chemistry part of that, but you might spot the end bit, the amide part, which means it's made out of a combination of polyamide, i.e. nylon, and polyether, which is the flexible part. What you get with the combination of those two materials is a bunch of properties that aren't exactly like your standard TPU flex filament, and not many downsides compared to TPU filament. If you've ever printed a ball out of TPU like this one, you'll soon discover that it doesn't bounce. This is one of, if not the main marketing point of PEBA. It has what's known as a higher elastic recovery than TPU. Also, I just want to take a moment, it's entirely unrelated to the video, but I just want to say I was right. In my last video, which was a review of the Snapmaker U1, I said, did I not, that this will be, well, huge. I think I said one of the most important printers of this year. It seems like that is actually the case. Anyway, in fact, prints using PEBA will have a much higher coefficient of restitution than most other print materials, if not all of them, which in non-engineering terms means more bouncy. If you want bounce, you want PEBA, but I'm not just going to tell you that, I'm going to prove it in a minute. This orange stuff I showed you earlier is from Big Tree Tech, and they sent it a while back under the name Flexible PLA, I think. It was for printing basketballs. I have reason to believe, I can't prove it definitively, so I'll choose my words carefully, but it would appear to be the same as this WizDream stuff on Amazon. Neither of these companies are telling us what this material is, but I can tell you it's not PLA. Similarly, with this FlashForge Flexible PLA, bit of a tongue twister, although the datasheet on this stuff implies heavily that it's something called PBAT, P-B-A-T, not the same as PEBA, P-E-B-A. I'm testing this stuff alongside TPU and PEBA, and I think it will make sense at the end of the video why I'm doing that, or actually, maybe it won't, but we'll see. At least in a minute. This PEBA Air, we're jumping around a bit, I know, I realise that. I can't think of any other way to present this. This PEBA Air is the very same PEBA as the normal reel of PEBA that I was just talking about, but it has a foaming ingredient in it that activates, just like VarioSure, if you saw the video before. It activates with temperature. Of course, this is the 3D printing macro lens channel, so it still looks either gross or cool close up, depending on, I guess, whether you're eating at the moment. Even if you saw the last video on foaming filament, you probably have forgotten how it works. I have to admit, so have I. I said it foams by temperature, but you need to allow it to expand, otherwise it will presumably either make a mess, or more likely it just won't expand. It will stay in an unfoamed state because it has nowhere to foam to. You just have to give it somewhere to expand out into, and you do this by using one single setting in the slicer, and that is extrusion multiplier and Prusa slicer, and the same setting is called flow ratio in Orca Slicer. This, essentially a multiplier, does as you expect. 1 means no change to the flow rate. Below 1 means you're lowering the flow rate compared to normal. As you see, Soraya Tech have given us useful start points for how much to reduce the flow by for each temperature range and what that means in terms of the resulting hardness, because that's what happens when you foam this stuff. It gets softer because it's less dense. It's got air in it. That's the whole point. So what you can do, in fact, is make 5 copies of a PEBA profile. That's just a modified TPU profile with, I think, slightly hotter. And each one of these 5 copies has a change in just the print temperature and the flow rate. That is all. And you can name them by the expected hardness. So you end up with 5 different hardnesses that you could just select at will. I thought it's worth running a test print at all of these hardnesses, all these profiles, and the other materials too, just to see how close they are to what you expect. And the answer is, well, this is kind of what you'd expect probably. You aren't necessarily getting very fine control over the parameters you're putting in, if that makes sense. You don't necessarily know the actual temperature the actual filament is being flown through at, because you're only heating up the nozzle, you're not heating up the material. Anyway, you don't know whether the blocks are 100% solid. There's a few kind of variables that you don't exactly have control over, so you expect some deviation from the expected values. There isn't really much deviation you can see, so in my opinion, these values are good enough. If you really cared, you can note those down and reference them back. So in my opinion, these values are good enough, and I'll share these profiles for the Core 1 over on Patreon for anyone who wants them, along with the original PEBA profiles that I made. I've made those for a couple of machines, Core 1, Snapmaker, Elegoo, Centauri Carbon. What's also not that interesting is the other 2 mystery flex filaments are showing us 92A shore hardness. I don't know what you can gain from that, apart from obviously now we know the shore hardness of those filaments. I suppose that affects the printability of the filaments, so now you know they're 92A. If your printer can't handle that, then don't bother. As for printing this stuff, it is actually pretty easy. PEBA seems to stick to PEI bed surface surprisingly well. So well, in fact, that I started using glue stick so that I could get it off easier. It is recommended to use a heated bed. I'm not sure it needs it on PEI. What matters more than anything else is extruder design. PEBA is still the same shore hardness as TPU, but it is more elastic, meaning it poses more of a challenge to, among other things, the extruder gears. Specifically their spacing and their ability to grip the filament. It will quite happily slip in the extruder if you don't have a really good spacing between the wheels, for example. The Core 1 works, so the XL probably should. It's the same extruder. The Centauri Carbon works. Snapmaker U1 works. I haven't tried others, but if you struggle with TPU, you will definitely struggle with PEBA. So AMS or MMU type systems are definitely out. Anyway, before we get back onto the bounce stuff, we'll talk about why you would even want foaming PEBA as opposed to PEBA. But before we do that, we'll talk about this video's sponsor, PCB Way. If you're a maker or just a 3D printing hobbyist, which you likely are if you're watching this video, then you're going to at some point have to deal with electronics as part of your designs. I do quite regularly myself. In fact, I'm actually halfway through about 3 projects simultaneously that will need electronics integrated into them in some fashion. I used to be one of those people who would make an entire design on a breadboard and then just call it quits and use that breadboard permanently. There's actually some evidence of that on this channel if you go back far enough, but that's not a great idea. Nowadays, I actually do design a proper PCB for most of my circuits, not just because I'm sponsored by PCB Way, which admittedly is an obvious consequence of that, but also because I want my creations to be more reliable, neater, smaller, and just look aesthetically better. I think it took me about a day or 2 to get to grips with how to make a PCB in the first place. If you just need the basics, it doesn't take that long. If you've never done it before, then there's plenty of resources out there, like videos, tutorials, and I've done one myself, a very brief one. And making PCBs with PCB Way is also incredibly easy. In fact, most of the fields on their order page are already defaulted to the ones you probably want to use as a beginner. So all you really have to do is upload your files, check it all looks fine, choose a colour for the silkscreen and solder mask. That's the colour the board is going to look like in the end, of which there are many, including this amazing purple that I particularly like. So if you also find yourself in need of a PCB for your hobby or work for any reason, or indeed any of the services that PCB Way offers, of which there are many, including CNC and 3D printing, then I suggest checking them out at the links below. If you check the description on this video, you'll also find a code for first-time users, which will give you a discount. Thank you PCB Way for sponsoring this video. So, in terms of applications for PEBA and foaming PEBA, I think you have industrial applications which will leverage the chemical resistance and longevity, especially if it's required to be flexed all the time. In fact, PEBA doesn't contain plasticizers, unlike many plastics including TPU, and most of us have probably experienced plasticizers leaching in the past. It's that thing that makes rubberized grips go sticky. So, just for that alone, I would be sold on using PEBA instead of another plastic. For hobby applications, I think it has huge potential in cosplay, especially the foaming version. I've seen people using VarioShore for cosplay more recently, and it always looks really cool. You've got the same effect again with PEBA Air. You get this matte finish, and it sort of looks a bit like EVA foam. It's also significantly lighter than a TPU print of equivalent print density would be, with the same infill settings. And PEBA is also just a lighter material than TPU, even just naturally before foaming. So that seems to be a no-brainer from that respect. So finally, let's get to bouncing. What I did was hang a tape measure and drop identically printed completely solid balls onto this slab of marble. The reason we use a slab of marble is because we want the surface the ball's impact to be uniform but also not absorb any more of the energy than it has to give the best bounce, basically. I dropped each one from slightly off-camera height of about 40 centimeters, just slightly higher than you can see, and I filmed it, as you can see, at 300 frames per second, so as to be able to see pretty accurately how high the balls go on their first bounce and their second bounce. This is not very scientific, as the balls aren't perfectly round or even close to round due to overhangs and other stuff, and that means they don't always bounce straight, and of course I can't always drop them uniformly. However, we did get some pretty consistent results, which I was quite surprised by. I thought there would be some variance there. And we did get some pretty interesting results as well. We need to figure out what this means. Firstly, TPU doesn't bounce. We knew that, but no, it really doesn't bounce. This is because while it's happy to deform elastically, that's what it's known for, it doesn't rebound. This is because the coefficient of restitution is low. Secondly, these two mystery filaments both do bounce. The PEBA bounces the most out of all the materials, which is exactly what we expected. It has a really high return rate of about 27 centimeters when dropped without any force from 40. I did expect the PEBA Air to bounce less high due to the addition of the additives and potentially the foaming as a physical thing. That might have helped or it might have hindered. My guess was it would hinder, and it seems like that's correct, or at least as far as you can tell. It performs much closer to the FlashForge and the Big Tree Tech stuff with still an impressive bounce, considering. Worth noting that once the PEBA Air ball gets light enough, it's affected by external forces too much, and you can't bounce it very accurately, hence the weird numbers there. It just isn't behaving properly. Finally, at least in terms of observations, I randomly printed out a ball at lower infill, a bigger ball with two walls, and it bounced way better than any of the ones I've just tested. This is suggesting that solid balls aren't necessarily the optimum solution for bouncing. I don't want to get too deep into this because I think it's a rabbit hole and it could make the video twice as long as it is. That's my theory. It would be cool to see this mid-bounce at a higher FPS on a higher speed camera. Maybe I'll do that in the future. I just didn't have time to get into that because I think it's probably really hard to set that up. But there's obviously a sweet spot in terms of infill and number of walls that will give the biggest bounce. So in summary, we have two types of PEBA. One bounces really well and has a bunch of other superior properties compared to TPU. The other one bounces slightly less well, but it still bounces really well compared to TPU, and it can be foamed to make it lighter for any purpose where you might want a lightweight but relatively indestructible, flexible part with a matte finish. If cost isn't an issue, and remember that you might get up to 50% more out of a reel by weight because it foams, but if cost isn't an issue, then it's hard to see why you wouldn't choose this over TPU in a lot of applications, if not the vast majority of applications. Obviously, at the time of the video, it's available from Siraya Tech in any colour you like, as long as it's black. But I think more colours are on the way from them. And of course, more manufacturers do exist. Sunlu have already told me they were actually going to send me some PEBA, but it just hasn't arrived in time for this video. They are starting to make it themselves. Other manufacturers probably going to follow suit. I think it might become an increasingly popular material, and I hope so, because if it gets more widely known and more widely used, I think a lot more people will find it useful alongside and indeed instead of TPU. I think we could very well find ourselves in a situation where PEBA becomes more popular than TPU. I'm not quite willing to predict that, but I could see it. Anyway, that's about all I have for PEBA. Let me know in the comments if you have used it or plan to use it or are interested. Remember to like and subscribe, because if you're not subscribed, you probably will miss stuff, and you might miss stuff even if you are, apparently. I will see you next time. Thank you for watching.